Hello friends, this video on integrals part 4 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 4. Let's learn some properties of indefinite integral that will be helpful to solve the integral problem easier in a faster way. The first property says that you take derivative of fx, you integrate this with dx, you get fx. That is f dash x dx, integration nothing but fx, or other way around, you have fx dx, this integration value, you differentiate this, you get fx. Please note, in both the case we are getting fx. So you integrate the derivative or differentiate the integral, both are same, that is alright. You integrate derivative or you differentiate integral, both will give you fx, correct? So you have a derivative, you integrate this, the first case, you get fx plus c. You have an integral, this guy, you differentiate this guy, you find derivative of this, you again get fx. The second property says that two definite and indefinite integrals with same derivative leads to same family of curves and so they are equivalent. This is, we have seen example, we have fx is equal to 2x, right? And we got the integral was I think x square plus k. So we got so many curves, but they were all equivalent curves and belong to the same family. You have fx plus gx, you integrate this is nothing but you integrate fx first, you integrate gx first and then sum, or you first do the sum and then integrate, both are one and the same. For any real number k that is constant, because k is constant, is real number, you say k fx dx, or you can take out k outside, right? If you have k inside, you can take this guy k outside, this guy. For example, I tell you, you have, let's suppose 5x square dx integration, this is nothing but 5 constant x square dx. We'll solve some questions and this concept will be clear, but the constant part, the real number parts, you can take outside. The next one is nothing but the merge of these two. You merge these two, you get this, that is, you have some constant into function, constant into function. So many functions, so many constant, this is nothing but you take this constant first function, add again constant to function, you keep doing this till n, k and fn, both are same. This is nothing but the merge of these two properties, you get this property. So what is this? The first is you integrate a derivative or you differentiate an integral, both are same, you get fx. Then you have this number, you have two indefinite integrals and they are all different curves, but they are all same family of curves and they are equivalent. And you have fx plus gx, you integrate, or you first integrate fx and then integrate gx, you sum, it's all the same. If you have a constant real number k, you have k fx dx, you can take the k outside. So let's prove this first property. The first property says f dash x dx integration is nothing but fx plus c. So we know that f dash x is nothing but d by dx of fx. This is something which we know, correct? Let's integrate both sides. So you integrate both sides, you get integration of, or integral of fx dx is nothing but integral of d by dx of fx. And this is nothing but fx plus some constant, correct? You integrate a derivative, you get function, and this is nothing but my first property. Let's try the second property. In fact, if you see here, we have used this second property which I am going to prove now. This is nothing but my second property, right? So let's prove the second property now. Let f be antiderivative of small f. I'll write here. Let capital Fx be antiderivative of small x. That is d by dx of capital Fx is equal to small fx. Correct? Now let's integrate both sides. So if you integrate this guy becomes fx plus some constant, and this guy becomes fx dot dx. Correct? Now I have to prove this guy is nothing but differentiative of integral. So let's now differentiate both sides. So if I differentiate this guy now, d by dx of fx plus c is nothing but d by dx of integral of fx dx. Correct? This is my part, and this is equal to this derivative of fx plus c, and derivative of fx plus c is nothing but fx. Why? Because this guy is nothing but fx. Correct? If you see here. So thus we can prove this also. So what we have seen here, you take a function, integral, you find derivative, that is derivative of integral is equal to function, or you have a function, you take the derivative, find integral, that is integral of derivative is also a function plus c. Let's prove the second property. So if I have two functions, let there be two functions f and g such that derivative of fx dx is equal to derivative of gx dx, and we have to prove that integral of fx dx is equal to integral of gx dx plus c. Please note, we have to prove this given the derivative of this guy is equal to derivative of this guy. Proving this is very simple actually. So this is equal to this given, so I can write this as d by dx of fx dx minus d by dx of gx dx. Correct? This is equal to 0. Because this is equal to this, so this minus is equal to 0. Now let me take d by dx common. So what I'll get is d by dx of integral of fx dx minus gx dx, correct, is equal to 0. Or derivative of something is equal to 0, that means that function is constant, or I can take integral both sides. So what I get is integral of derivative is nothing but function, so that is nothing but fx dx minus integral of gx dx, and this becomes constant. Why? Because it is 0. For any 0 number you find an integral that is constant, and that is what I have to prove. So you see that I have proved this. So very simple, just I had this function, I found derivative, and I found integral was constant, and thus I can prove that integral fx dx is equal to integral gx dx plus c. So the point to note here is, if there are two functions and the derivative of those two functions are equal, that means those two functions are similar functions and they differ by constant. You see, this guy and this guy has to be similar. Why? If the derivatives are same, that means these two guys, the one inside the square box or rectangular box, has to be similar. So this whole thing is similar to this whole thing. Since it is similar, you have a constant because you can move the curve up and down. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.